Karen, could you please start the webinar now?
Hello, good morning. I'm Karen Moreno. I hope you can see me here in this presentation. Well, we are very pleased to get the organization of this seminar about the techniques of micro CT that we can use in paleontology, in biology, and many other areas. This seminar will be in English, of course, but it will be translated in the all along the presentations. This is a live webinar, so you will have a one-to-one presentation, and you will be able to make questions at the end. There is a button, questions and answers in the lower part where you will be able to put all your questions, and at the end we'll be able to reply. So now in Spanish. Muy bienvenidos a este seminario que va a tratar sobre todas las tecnologías de tomografía computada, que está haciendo una revolución sobre todas las ciencias de la vida, y sobre todo tenemos el interés en paleontología, para que armemos un grupo de trabajo que sea posible de desarrollar estas técnicas en Latinoamérica, principalmente, en donde tenemos esta falta de análisis. Desde la Asociación Chilena de Paleontología hemos querido apoyar esta iniciativa para generar este nuevo desarrollo de la ciencia aquí en Latinoamérica, y Comet Yxlon está haciendo un enorme esfuerzo por ayudarnos a tener esta conexión y este desarrollo. Well, the Chilean Association of Paleontology is supporting this organization because the idea is to make a collaboration that will be possible to do this sort of analysis in Latin America, which is lacking of this opportunity. So we're very happy to have Comet Yxlon helping us to build up this community interested in this sort of analysis. So I will introduce you to Kornelius Kupzic. He's a paleontologist as well, working in Chile, just as I am. And we're both trying to push this together, and he will be presenting on what each of the speakers will be talking about. Así que presento a Cornelius Kupzic, que va a estar hablando sobre, es un colega también chileno de la Universidad de Chile, que estamos empujando toda esta iniciativa, y él va a presentar y explicar un poco qué es lo que va a hacer en las próximas charlas. Cornelius, todo tuyo.
Muchísimas gracias, Karen. Thank you very much. Also for me, very good morning, very good afternoon from wherever you are. Muy buenos días, muy buenas tardes a todos que están aquí presentes, aquí en Chile o en la región o fuera, incluso en Europa. Sí, como Karen dijo, voy a presentarles brevemente a nuestros speakers, nuestros presentadores. A Karen y a mí ya han visto. También tenemos a la Natalie Resnikov. So, brief introduction to the speakers today. You've seen Karen and myself already. We have Dr. Natalie Resnikov from McGill University. We also have colleagues from Comet Yxlon who are supporting us in presenting this webinar. Podemos contar con estamos muy agradecidos por el apoyo de nuestros colegas de Comet Yxlon, Christian Johans, Erika Sales y Joseph Parientes. And I will show you I'll explain you briefly what the program will be like. You've heard our introduction. We will be talking about, or Christian and Jill will be talking about micro-C systems and possible applications in paleontology and anthropology and beyond. We'll also be hearing from Dr. Erika Silva-Sales about visualization and analysis software. And last but not least, Natalie Resnikov will be giving us some examples, some case studies with the title, What is Inside the Bundle? The idea, of course, for this webinar is to promote this type of technology, particularly in Chile, in the region. And for this, we're very grateful for these speakers and also eventually for your questions and hopefully answers. El programa, como mencionamos ya, es introdujimos este webinario. Vamos a escuchar desde Comet Yxlon sobre los sistemas de micro-TC y sus posibles aplicaciones en la paleontología, antropología y las ciencias biológicas. Vamos a escuchar sobre software de análisis y visualización por parte de la doctora Erika da Silva Sales. Y vamos a tener unos casos de ejemplos, casos de estudio por parte de la doctora Natalie Resnikov. Y finalmente, para ustedes también tienen la posibilidad de hacer preguntas a nosotros y los otros speakers. Siempre pueden utilizar la caja de Q&A para hacer preguntas. Y si no llegamos a responderles todo en este tiempo, también vamos a ponernos en contacto con ustedes. Bueno, entonces ahora mismo voy a pasar la palabra a Christian. Now we'll pass on the word to Christian Johans for the first presentation.
Hi, everyone. So just before Christian shares his part, my part's really small. I just wanted to introduce myself. My name is Joe Barrientos. I'm with Comet Yxlon. I'm the sales manager for Mexico and Latin America. So if anybody has any questions after the meeting, please feel free to reach out to me. And now I'll pass it off to Christian.
Hello, everyone. Thanks for joining today. I hope everybody can hear me and the subtitle works and makes sense. Very welcome to today's webinar, Gentle Inspection Methods, CT in Paleontology, Anthropology, and Biology. As you already seen, my name is Christian Johans. I work for the Comet Group, but we'll come to this later on. So I thought about today's webinar and just want to put it in a nutshell. And the reason why we're doing this, especially for the scientific community or natural history museums. And it's always great to start with a globe. So, and the fact that we're collecting specimens all over this globe. And the actual living specimens and they are actual living animals and maybe animals or beings that are already gone. So we collect those and most of the time store them in museums. So what do we do in these museums with those specimens? They get stored for scientific research, for documentation of biodiversity, education and outreach, for comparative anatomy, climate and environmental change studies, historical and cultural significance, conservation, and long-term preservation. But what are some risks we face that here? We have environmental factors like temperature and humidity, pests or light that influence the condition of the specimens. We have risks in handling and transportation, like mishandling, theft, or vandalism. We have the collection management and cataloging errors, or budget and resource constraints, maybe a lack of funding, or natural disasters like earthquakes, hurricanes, tornadoes. So all that bear risks for making sure the specimens that have been collected with hard work get secured in some kind of way. And this is how I transfer this to YCT in this case. So what are the advantages here? I make that as an example of a gorilla skull here. So on the left side, you see the specimen itself. And on the right side, you see the digital clone of it. This has been done with a CT system. And what are the benefits? So digital twin that ensures the current status of the specimen itself. We have the ability to send the data around the world without the part leaving your facility. And we can study those parts without destroying them. Just 3 benefits, but there are multiple more. So, right, we can analyze them. So we don't destroy it, and we can do our analysis on that and share it. That's kind of the core value of that. And this comes to me describing who we are. We are the Comet Group, and we're operating all over the world and have multiple companies. So in Switzerland, we manufacture our X-ray tubes and plasma control units. In Hamburg, where I am, we are manufacturing the CT systems. In Canada, we have Erica here working for Dragonfly. And as Joseph already said, he's supporting us in America. Right, in Hamburg, we manufacture those CT systems. You see our manufacturing hangar here. We have an application hangar as well, where we have the possibility to store all our systems for demonstrations. So if you're ever in Northern Germany, let me know. We have representatives in more than 50 countries to cover all the job that has to be done to support our customers. The systems, and I keep it roughly with an overview. As I said, we manufacture X-ray and CT systems for different categories or industries, if you want so. So on the one for semiconductors, for electronics, for automotive and aerospace, for tires, but the reason why we are here today, for science, research, and development. So for that, we have systems allowing you to get a very high precision, a solid intuitive work, and this leads to a high resolution scans of the specimens. From that, we have medium to large size equipment. And yeah, if you have questions, of course, please ask them. So I took as an example, and for the ones who might not be too much into CT, so I just give a rough overview what it is about. So you see here one of our medium-sized CT systems, the FF35. It comes with 2 X-ray tubes and a medium-sized scanning volume. That's the part on the right side, and on the left side you see 2 monitors or 3. But on the left side, that's the reconstruction. So this is the place where you work on your data. And on the right side, that's with the 2 screens, that's the area where where the human-machine interface is to work with the system. When we have a look inside the system, it looks the following. We have the detector over there, behind the screen there, a manipulator in the center, and the tubes on the right side. So for this tiger skull, we used, for example, a 225 directional tube. The X-ray source. So coming to the part 3, the examples, we decided it's a good idea to get an insight in what we do for natural history museums, for example. I start with the dinosaur egg we scanned recently for a wildlife park in Lüneburger Heide, northern Germany. They collected 120 million years old eggs from Mongolia, about 30 centimeters in length, so 2 of them connected to each other, and about 17, 18 in width. Here you see my colleague Muofichu Balanganda from South Africa, our application engineer in Hamburg, setting up the scan. So what means setting up the scan? So inside a large system, it looks like that. 2 tubes on the right side, 2 different kinds of detectors on the left side, allowing us getting large scan volumes done, and the X stored in the center on the manipulator. So what we did here, we did an overview scan on the X to just get let's say a rough insight into the in the X, and then we decided afterwards to get a more detailed insight. So we reached 53 microns here, and this is a classic circular scan. So you rotate the part 360 degrees, it captures each step a 2D image, and with a reconstruction, you get a proper 3D image. So a 3D image could look like that. I hope the frame rate is as accurate as I see it on my side. So you see here the 3D rendering of the 2X, and in a few seconds we cut the part off. So this means you get the 3D image, and you get each slice by slice millions of points showing you the inside material. But this is just a 3D. When we have a look at the computer tomography picture, so stack image by stack image, you can see all the details, allowing you to do the inspection. And again, you don't destroy the part, you can inspect it, and unfortunately figure out that there is no bone structural material inside those eggs, unfortunately. The second point is I took a fish fossil. The interesting thing about this is normally CT has its limits when it comes to magnification. In this case, we use a so-called layer scan or 2.5D scan, or maybe laminography, different words for nearly the same topic. In this case, you have the possibility to scan a very flat, large sized volume and get a very high resolution, allowing you to get a detailed view on the structure and everything you see there. I took a frog. This is a scan we did a while ago, but this was a very good example to show what we do to inspect, maybe, for example, the soft tissue, but without destroying anything. So this little fellow over here was not destroyed in this case. We put it in the system, took it out of alcohol, put it in the system, and then you can put it apart from each other, layer by layer. The fourth example here is the harbor seal skull. We did this inspection for the University of Kiel for Dr. Böhmer, and here the task was to do the inspection, an overview scan, but then, and this is a little bit more detailed and interesting, get a view inside the skull, the so-called nasal structure here, and show the benefits of new trajectories in the market to get even a higher resolution. So the overview scan, again, you can see the tomography pictures, or you can render 3D images of your part for presentations or presenting your work. The second task, already as described, we did a comparison of our new technology we are releasing since September last year. So the nasal structure scan itself looks like that when you use a classic CT scan. When you use our new scan trajectories, you see on the right side, you can intensify the resolution, allowing you to get a more detailed view on that. And what do we do with this? In this example, we used a deep learning algorithm coming from Dragonfly, allowing us to easily segment areas with different sizes and then get the 3D volume out of this. So this looks like that. This is the 3D rendered segmentation of larger nasal cavities and smaller ones. And the other example is marten skull. I put a picture here because this is what they're famous for. This is a skull we received from Kornelius Kupzic, who is also here and already talked. Right, so here the task was to get the highest resolution possible, especially on the teeth. So we made first a normal circular scan with a 30 microns voxel size. This is what you see there. But then the goal to intensify the resolution was to use so-called zoom CT mode that allows us getting very close to the mandible and getting a very high resolution scan. And yes, this is what you see here, and this is what you see in the comparison when you we took the mandible itself and tried to get as close to as possible with new trajectories. So this is what you get with a normal scan, and then with a very high detailed scan. And last, I think it's the last one. I'm not pretty sure. Maybe I have a little surprise. We'll see. I forgot what I put as an example 6. The mouse skull, we have multiple examples, so sorry for that. A mouse skull here, and there the goal was to get a very high resolution on the area over there. And we managed that with a resolution of 2.5 microns. So what can we do with that? You see it in the 3D image. You can have a look at the dentin, the pulp, the animal over there. Do your analysis, in this case with Dragonfly, or do a wall thickness analysis of the mandible structure that shows you the wall thicknesses of segment by segment of the bone here. That's it from my side. So yeah, thanks for being there, and I hand over to Erica. And yeah, thank you.
Hang on. Just a little announcement, si hay preguntas por parte del auditorio, pueden hacerlo en el chat de Q&A. So people, if you have any questions, you can put them in the Q&A box. Yeah, and we look into this and get them to answer either in the chat box, or the speakers will also be able to answer them at the end of the seminar. Thank you.
So hello, my name is Erica Sales. I'm the Global Application Engineer for Dragonfly. So for those that don't know, I don't know why okay, it seems okay, I need to use here. Okay, so those that don't know what Dragonfly is, Dragonfly is a software platform for scientific imaging analysis. Let me see if I can get a ruler here, a pointer actually, sorry. So here on the right, you can see a screenshot of our main interface where you can just import your data set. And once you import your data set, you can visualize your data set in 2D and in 3D. You can also perform measurement and inspection using Dragonfly. Image processing, we have many tools for example, image filters, and we have also image segmentation, where you can just use a threshold to segment your image, or you can use automatic thresholds such as Otsu. And we also have the powerful of deep learning for segmentation. In Dragonfly, you can also use many quantitative analysis tools for volume, porosity, wall thickness, and you name it. You can also do some animation in 2D or in 3D, like you can make some videos of your sample, like you can rotate and change the color, the transparency. There are many applications for animations as well. And the good news about Dragonfly is that Dragonfly has a free license we call the non-commercial use. So if you are research, if you are in academia, you can request us a free license, okay? So Dragonfly support many image technologies such as spectral image, high resolution microscopy, optical microscopy, and computed tomography. And we have several areas of application, which include material science, life science, geoscience, industrial inspection, special collections, and food. So I cannot talk about everything today to you, so I'm gonna show you a little bit of examples in life science and special collections today. So Dragonfly, it's very powerful as well for 3D volume rendering. You can create impressive image using Dragonfly. It's used to use, and you can have a wide range of options for visualization appeal, such as you can use some lightnings in your 3D image, like put some lighting in one area and use some shadows in other area. You can also use some reflective floor that you can show another part of your image that's not visible in that plane, so you can see another plane here. We have many lookup tables where you can change the colors of your sample, and we have also like presetting for segmentation, like you can use some bony presettings of some rock presettings, plastic, and etc. So in the 3D rendering, you can also use some kind of transparency in your data that segment, and that will help you to show, for example, in this plan, all the cells that you have inside of this plant here. So Dragonfly, it's very well known in academia. We have many users worldwide, so many people that have been using Dragonfly in their publications. So here I got this one that was published this year, where this group is using Dragonfly to show their data in 2D and in 3D. And this other publication here, this group is using Dragonfly, actually the deep learning segmentation Dragonfly, that's very powerful. So they are analyzing the shelling invertebrates and their fossils. Like, I know that's quite complicated sometimes for you to segment fossils, because the difference between sometimes like structure, it's very similar. And so Dragonfly deep learning segmentation can be a powerful tool when you have such difficult image to be segmented. So in this case here, they could use deep learning to separate the shell from the matrix and from the air. So Dragonfly deep learning is not limited to image segmentation. We also have deep learning for object detection, the noise, super resolution, image contrast enhancement. And when you are working with image segmentation, you can apply deep learning in 3 types of scenarios. One, you can just train a model and apply the segmentation to a single volume, or you can apply to multiple volumes, or you can even train a model with different modalities, as for example, you can have a micro CT and a FibScan image, and you can just train a model to segment them. So you don't need to be an expert to use deep learning in Dragonfly, okay? So we have what we call segmentation wizard. So this is as you can see, it's a different interface as the other one. So here in the segmentation wizard, we have like painting tools or ROI tools, where you can just create some frames. So this frame is gonna be your ground truth for your deep learning model to be trained. So what you need to do is just painting some frames using the painting tools here on the left. and then create the classes, as you can see here on the right. So the green class here is my background. The yellow one is the tooth. The red one inside of the tooth is pulp. And then the blue one around the tooth is bone. Okay, so once you create frames in Segmentation Wizard, you can also create another frame that I'm calling here monitoring. It's not showing here, but you can see here. And you can play train. So before I go there, actually, I want to talk about that Dragonfly has many deep learning models that you can just use the models we have that we call pre-trained models that was trained by our engineers. And you can just use these pre-trained models in your data. But if you have already some familiarity using deep learning segmentation, you can also create your own model and change all the parameters. So here, when you just click train your model, you're gonna have all the parameters here. You have your frame that's here monitoring, like showing what your model is learning from those two frames, and showing how the model is segmenting your data. So once your model is well trained, you can just apply this model to your whole data set. So this is the result I got from this the Martin School. So and I forgot to say that this is the sample that we have scanned in Germany using our FF35 system. So here in yellow, you have all the teeth, and in blue, you have the bone, and inside of the teeth, you have all the red, that's the pulp. So in Dragonfly, we also have what we call noise to void model. That's a deep learning based image denoise. So different from a segmentation wizard, you don't need to create frames and paint the frames to do a denoising, okay? So you just need to create a region of interest and apply the model to learn about this image and learning how to denoise this. And this is the result you can get from this model. Another deep learning solution in Dragonfly, it's called super resolution. So sometimes you are doing research and you need to use a very high resolution that's gonna take a long time of scan, and you maybe need lots of exposure time, and this can damage your sample. So if you have many samples, that can be very cost, and at the end you can just lose your samples because they are gonna be damaged. So one solution that we have, you can just image one of your samples in high resolution and then apply a model to learn from this high resolution scan. And then for your other samples, you can just do lower resolution scans. And then in your lower resolution scan, you use this model that was trained with the high resolution, and you can get an image with a better quality. So it's like you were using deep learning to get a result closer to a high resolution scan. So Dragonfly has many tools for quantification. As I mentioned before, you can quantify porosity, wall thickness, and etc. But something that's very used for paleontologists, it's the bone analysis wizard. So in our bone analysis wizard, you can do a morphological quantification, as you can see here in this table, for cortical bone and trabecular bone. Also, if you have a phantom, you can calibrate your data set, and you can have bone mineral density analysis of your sample. Another tool in bone analysis wizard is you can, if you're working with bone biomechanics, you can do some anisotropy mapping, as we can see here in this image right on the top, where in this mapping, you can see the magnitude of anisotropy being high in this region and lower here in this region. You can also get the values of anisotropy for MIO or SVG algorithm in the table, or you can have a mapping, as I said before. You can also do a trabecular bone mapping or thickness of your sample. And you can also do some anatomy analysis. When you have like long bones, you can get the mass and min of your long bones and moment of inertia and polar moments and etc. So how can you contact Dragonfly? So you can go to our website, theobject.com Dragonfly, and you can request a trial version. Okay, so you can get like a 30-day trial version. And if you like our software, that I'm pretty sure you will, you can ask for a non-commercial license, as I said before, if you were doing research. Okay, it's gonna be free. You're gonna have a Dragonfly, the license for Dragonfly, or you're gonna pay anything for that. If you go to our YouTube channel, we have many materials there for people that it is not familiar with Dragonfly yet. So you can just go there, and we have some tutorials showing you from the basic, like how to install Dragonfly, how to import a data set, how to crop your image, and etc. And then you can go for more advanced a little bit, go for deep learning segmentation, how to use the segmentation wizard, or do some object analysis for quantification, and etc. So if you have any question about Dragonfly, you can contact me, and I will be very happy to help you with your requests. And that's it for me today. So thank you so much, gracias. And Natalie, it's with you. You are mute, Natalie.
Okay. Hi. Hello. Can you hear me?
Everything works well now.
Super. So I'm very happy to be here, and thank you for inviting me to present my story in this mini forum. I will present a very new project that we just started several months ago, so it's a work in progress, and we are focusing on the study of ancient Egyptian mummies. So to start, I would like first of all to acknowledge my colleagues, without whom this endeavor would be impossible. And well, first, great thanks to the Red Path Museum curators, Annie and Anthony, who enabled us to, who gave us the precious objects on loan and allowed us to scan them. And then very enthusiastic and brilliant students, Maris, Schumann, and Sala. And my colleagues, professors, and friends who put the proposal together and are now helping to drive it. So the project on Egyptian mummy imaging has two phases, or two axes, so to say. The technical aspect of it is to refine the algorithm for super resolution, which means to marry two normally incompatible ways of imaging. One way is to cover a huge contextual volume of your object in full, and another aspect is to get the finest detailization and sharp definition of features. Usually you can get one, but not the other, and we are trying to design a flexible and user-friendly algorithm for doing so by acquiring images at different resolutions and then training a neural net to do the job for you. And the project, the second axis, the second aspect of the story is more basic science oriented, and we hope to get a better idea of the biodiversity of the ancient Egypt, and we want to learn how to identify the species of animals and to better understand the relationship between animals and humans in the past. And of course, it has an emotional side to it because we all love animals and mummies. So the study has many moving parts, and on the left you see a photograph of yours truly and my colleagues Andrew Nelson with the beard from the Western University of Ontario. Andrew is an anthropologist, and Mark McKee on my left side from McGill University, and he's a basic scientist and osteologist. And Vladimir Brailovsky from École des Technologies Supérieures is taking the photograph. And in the back, you see this brand new machine, FF35, recently installed here in Montreal. And on the right, there is a display vitrine from the Red Path Museum, where 5 mummies of animals are exposed for the public. So the first task that we had to accomplish would be to bring the mummies to the scanning facility and to image them safely, since they were preserved for thousands of years and we don't want to inflict any damage on them, and then to get as much information as possible from this fragile specimens. So usually we scan objects in an upright position because, as Christian explained earlier, specimens are rotating on the stage, and every 1/10 of a degree or so, a projection image is taken. But we couldn't do that with the fragile mummies because we were not sure that the interior of the mummified desiccated bundle will stay intact. And the condition of the museum was to provide as much support as possible and not to disturb the content of the mummy bundles. So Shumang, my student, who is a computer scientist, but turned out she's also a designer, she built a specialized custom stage in Blender and printed it and composed it from multiple parts. And now we had a safe and versatile way to mount the animal mummy bundles inside the scanner. We call it the cat's cradle. So when the object is inclined, we can shift with the help of the rail embedded in the design of the stage. We can shift the axis of rotation and center our area of interest, let's say, on the head end of the bundle, on the middle of the bundle, and then on the legs of the bundle, and then digitally put them all together. So that was the optimal solution that combines safety, care, and high quality of acquisition. We also learned that mummies are not the same, and Maris, who is a student in anthropology from the University of Western Ontario, filled us in. So we mostly are familiar from films with the sacred mummies, where the bodies of kings and priests and reincarnated deities were preserved and embalmed and stored for afterlife. But there are also other mummies. So in the afterlife, you presumably need many things, and these are called the victual mummies. And they were usually preserved as tomb offerings, and that would include well, food items, mummified, obviously, clothing or ritual objects. And here on the photograph, you can see there's a collection of mummified garlic cloves that embalmed emperor may use for spicing their mummified chicken. Also, humans, since the dawn of civilization, adored their pets, and pet mummies were common. So they were usually sacrificed and buried with their owner. But the mummies we had access to were so-called votive mummies. And votive mummies of animals are usually offered by citizens to particular deities, according to what kind of a favor a citizen would like to ask. And they can be compared to what modern Christian folks do with candles. Go to a temple, buy a candle, ignite a candle, and that is a ticket to get a favor from heaven. So because there is a monetary transaction involved in making and offering votive mummies, it also became a business in the ancient Egypt. So all mummies that we could image from the Red Path Museum here at McGill were these votive mummies. And we had access to one cat, 2 juvenile crocodiles, 2 falcons, and 2 ibises. So I will show now a few very preliminary reconstructions of the mummies. And here you can see 2 baby crocs wrapped in shrouds. And even if we do very simple segmentation, not even segmentation, but thresholding using Dragonfly, we can visualize denser parts inside the bundle, and you can see in quite great detail the bony structure of the crocs, their jaws and the tails. And this is a cat, and the cat wrapped in very elaborate ribbons of textile turned out to be a bit mangled inside, with bones mostly dislocated, but nevertheless we can say, well, it's a fully grown cat with all teeth in place. And these are 2 birds, 2 falcons that I believe are of the same species, because when we digitally unwrap the falcons, we can observe pretty much similar proportions of the bones and the skull and the ocular plates around the eye. And one of the birds is wrapped with the legs extended, and another one with both hips and knees flexed in position. Then we got to the ibis mummy, and ibises have this characteristic pear shape, with the head end being thicker and the tail end being thinner. So we crowded around the screen of the scanner and looked inside, and inside the bundle there was nothing. There was no bird, or just pebbles. And if we now have a look in 2D, you may appreciate that some of the rags inside the empty bundles were also imbibed with some very scattering material, which was presumably clay or dirt, that the artisan put in closer to the head end of the bundle to give it this characteristic flaring appearance. It was a little bit of a good news, because one of the pieces of textile has fallen off and descended to carbon dating, and we thought, well, would it be representative of the mummy interior? Turns out it is going to be representative, because there is nothing but textile in the ibis number 1. So then we looked at the second ibis, and we expected no trick there, because it has a plaque on it picturing a fully grown ibis bird. This plaque was painted with mineral dyes, so it is highly visible in X-rays. So we looked inside this beautiful object, digitally unwrapped it, just to find that instead of a fully grown bird, there is a little hatchling. Based on the cranial features of this little bird and the shape of the beak, we can tell that it is indeed an ibis, but the size of it is about 6 centimeters, size of a goose egg. So as Maris filled us in, pseudo mummies or counterfeit mummies were quite common back then. And these were the offerings that were shaped and embellished in a way that nobody would doubt that there is something valuable inside, but they could contain anything like rags or plant matter or mud or pottery shards or even bones of unrelated animals. And why would anybody falsify the ibis? Well, the reason is that ibises were really worshipped in the ancient Egypt because they were assumed to bring wisdom to the citizen who offers an ibis mummy to the deity. They were protecting peasants from plagues and serpents. So actually, there are really gorgeously preserved mature ibis mummies in other museums. And here on the right, I'm showing an image from the National Geographic where you can adore the full skeleton of an ibis and even can see the snails inside the stomach of the bird. And in our case, apparently, it was the demand that drove the supply and resulted in the cheat rate in our small sample of about 25%, where 1.5 of the 7 mummies available to us were counterfeit. But we treat it with respect because this is a snapshot on the human nature that apparently has never changed, at least in the past few thousand years. And there is more to follow as we continue analyzing these bundles in greater detail. And with this, I would like to thank you for your attention.
Thank you very much. Muchas gracias, Natalie, for your presentation, para tu presentación. And thank you very much to all the other speakers as well, of course. Christian, Joseph, and Erika. So muchas gracias a todos los demás también speakers, Christian, Joseph, y Erika. So let's move on to the questions and answers. Vamos ahora abrir preguntas y respuestas. Ya hay varias preguntas en el chat. There's a few questions in the chat already. But I would like to I think, go through them because I think there's two themes in here. I think one related to the CT imaging itself, and a few questions related to the image processing and the analysis. Bueno, hay varias preguntas, otras bloques de preguntas temáticas. Por un lado, como la tecnología, el hardware, el escáner, y por otro lado, la visualización y el análisis de estas imágenes. Entonces, quiero empezar con la pregunta de José Morales. I would like to start with the question of José, and perhaps Christian can add a few more words about the size. What kind of specimen size can we CT scan these days? ¿Qué tamaño o qué muestra, con qué tamaño podemos escanear en estos días?
Okay, hi. Unfortunately, this can't be subtitled because I'm not presenting anymore. So, concerning your questions, as I already answered, we can carry 1 meter to 2 meter and 400 kilogram at the moment in our systems. But if you want to have it very large, it really depends on what you want. And if it comes to large systems, we offer kind of more customized solutions, allowing you to cover what you need. But the geometry is very important to know about the part. And this gives an idea about the resolution we can reach. We have different techniques to increase the resolution, but sure, we need to know more. Unfortunately, this technique is quite complex. So, and the more complex the technique is, the more input information we need of what you want to reach in the end. But I hope this is roughly giving an answer. Please contact me and then we can speak about your part, and I can give you more detailed information.
Yeah, Christian, I think there is one thing that it can be as large as 1 meter or 2 meters, but actually the part scan is really, it have to be small, otherwise the amount of data that is generated is also difficult to get through. So,
definitely. I mean, sure, data handling is something that when you have, for example, a 1 by 1 by 1 meter scanning volume, and you want to have the highest resolution, it is you need a reconstruction PC allowing you to handle those data. And you know, when you want to have everything in 1 micron within 1 cubic meter, it gets a little bit tricky, of course. So this technique, as I said, it has its challenges, and for that we need to know what we can do with it. I mean, what you have.
So we translated. So, que en realidad esto puede ser cosas muy grandes, como de 1 metro por 2 metros, como ahí está en el chat, hasta 400 kilogramos, así que puede ser muy grande los materiales. Pero depende de la geometría, que tanta resolución se pueda dar. Y otro de los problemas que yo estaba resaltando ahí es como la cantidad de datos que genera ese escáner. Entonces tiene sus dificultades y hay que tener a alguien especializado en tratar de manejar ese tipo de exámenes, de análisis. Eso.
There's another important question about size. So, of course, in paleontology and actually working in natural history museums, for instance, often deal with large samples. But what about smaller size? Daniela Flores asked about the smaller size that one can scan, for instance, with one of your systems. O sea, aquí la pregunta es no solamente un tamaño grande, sino también qué tamaño o cuál es el tamaño más pequeño que se puede escanear.
Okay. Sorry, I was searching for the question.
It's
the smallest, the small site that we can scan. I mean, we go to, I mean, a few millimeters if you want, so because the limit is the tube itself, especially when you have a transmission tube. So you want to scan a small part. This transmission tube has its its spot directly physically in front of the tube, so you can come as close as possible to reach the highest magnification. So it's pretty hard to define a limit here. I mean, when you touch the tube, this is the limit.
Okay, but I guess and also for Daniela, maybe perhaps eventually you can also share maybe a few more other examples of small sized samples. I guess I'm sure that's possible. There's one technological question by Luis Chirino in the chat. What about when the fossil is rich in hematite, for example? So particular kind of mineral, in this case, hematite. O sea, ¿qué pasa si un fósil es muy denso, muy rico en hematita? En este caso.
Sorry, I need to check what hematite is. I don't know this English word.
It's an iron oxide. It's a very hard material that is actually in X-rays. It looks really, it's like metal. It's like
yes. Okay, metal. Sure. Okay, yeah. I mean, the thing is, especially when it comes to segmentation and fossils, and you have some elements that have a very high density, you have to make sure you get rid of the so-called artifacts you have within the CT scans. And for that, you can, on the one hand, filter with hardware, or on the back end, use some algorithms. We have one that's called scatter fix to get rid of the scatter to avoid any artifacts in the areas you basically want to inspect.
Thank you. Also, I hope this, Luis, espero que sirva como respuesta. I hope the answer suffices.
Sí, tratar de
There's one important question. Well, I find a very important question by an anonymous attendee about ¿qué planes hay para traer esta tecnología a Chile? Quizás para las investigaciones en el sur, en la Antártica. Also, that's an important question, I think, for you people from at Comet. So what about bringing this technology to Chile? For instance, in this case, in the south of Chile, there's research done, of course, well, the continent, but also in Antarctica. So for this very reason, this technology is very important. In yes, sí, eso es muy importante. Nosotros entre cada niño estamos pensando mucho en postular, porque nos damos cuenta que actualmente tenemos algunos sistemas de micro-TC contamos aquí en Chile. Sin embargo, como no siempre como se puede hacer scans de muestras grandes o muy densas. Y para este fin es importante pensar en esto. Y yo también en mi juicio y opinión también quiero decir que requerimos más de un equipo, más acá en Chile. Entonces, como sí, el enfoque sí está en Antarctica, por ejemplo, pensando en escaneando fósiles o muestras biológicas, pero también al mismo tiempo en otras regiones donde hay fósiles, donde hay museos de historia natural. También tenemos momias, evidentemente, aquí en Chile, en el norte. Entonces, para este fin también nos sirve contar con más de este tipo de tecnologías. So just to... Oh, Karen,
yeah, and to add up to that, we want also to reach to other countries that are close to us, so Argentina, Mexico, Peru, Brasil. Queremos en realidad que esta tecnología llegue a Latinoamérica y desde la asociación estamos haciendo el trabajo para, en primer lugar, empezar a desarrollar los protocolos de tránsito de muestras, que es difícil en nuestros países, para poder tener este intercambio. Es una visión a mediano o largo plazo, pero estamos ya trabajando en eso para que sea factible que este equipo se pueda también en el futuro ampliar la colaboración a Latinoamérica en total. Y esa es la idea de este seminario. So we want to widen up the reach of this technology to Latin America, and we are working on the procedures, the legal procedures for the transit of samples between our countries, which is right now is very difficult. But we're trying to work in that way so we can make Latin America a unified net of collaborators in this sort of analysis.
Okay, there's I think a few questions with regard to the software, to Dragonfly. Hay varias consultas y comentarios acerca del software Dragonfly. What I can see here from the chat, there's Alejandra Ortiz writes about, asks about whether there's any, other than the tutorials, which we can access, of course, by YouTube, are there any workshops planned? Alejandra pregunta si se puede realizar workshops, talleres, para conocer más este software de Dragonfly. Erika, for example, Erika or Joseph, can you perhaps answer that?
It's about Dragonfly, the one about Dragonfly?
Yeah, there's one by Alejandra, but there's more in the chat.
Dragonfly, workshops. Yeah, so we have several materials on our YouTube channel, like with many applications. Like if you have something specific, you can contact me and I can see where you can find the answer you need, or I can give you another video, something that can help with your research. Okay.
I think, Erika, I guess that would be fantastic for us as well. I mean, here in the region in Chile, Peru, Argentina, etc. If there was a chance to have maybe an online workshop, other than the videos, perhaps to offer like this type of workshop, a live workshop, that would be ideal.
Okay,
So I think-
yeah.
Yeah.
Okay, we can organize that, yeah.
And Javiera Delgado also asked about whether any studies on ontogeny been done using dragonfly. Rika?
Sorry, which one?
In the chat answer, there's a question by Javiera Delgado, whether any ontogeny studies or analyses have been done yet using dragonfly. So
It's a new one?
No, it's
at
been answered already.
11:47.
Yeah, that was the one she said she needed to follow up with, and we're going to reach out to her colleagues
Yeah,
and get
sorry.
an answer about that.
So I didn't see that, my bad.
So actually, the answer is it can be done. The thing is that the tool is able to, for the researcher to look for those anatomical data that can be interpreted as a young individual, as an older one. In the talk, there was an old specimen and a sub-adult ibis. And also some other examples of more adult animals. So this can be searched for in the software. Javiera, esto es una herramienta que se puede utilizar para ver los rasgos anatómicos con los que se puede identificar el estadio ontogenético que tiene cada una de las especies. Así que, aunque no se haya hecho, que sí mostraban ahí algunos ejemplos de un ibis, una ave que era subadulta, y habían otros ejemplos de adultos. Pero se puede enfocar a cualquier pregunta de estudio como la de ontogenia. Así que se puede.
Daniela works on embryology as well. Perhaps also, maybe one more also with regard to that question about bringing this type of technology to this region. If you are, of course, interested in well, learning more what we are thinking about as well here between Karen and myself, you can please get in touch with us. O sea, si hay gente aquí ahora mismo actualmente presente, pónganse en contacto con nosotros también para pensar en esto, si qué se puede hacer, cómo puede pensar en postulaciones, pensar también en qué tecnología ya existe, ¿ya? Para no repetir o hacerlo redundante. ¿Ya? Entonces, como pónganse en contacto con nosotros, conmigo y con la Karen, bueno, estamos muy bienvenidos de escuchar a ustedes también. So, yeah, please get in touch if you would like to join our effort in bringing this technology to.
De hecho, esta es una tecnología que es tan cara, es tan grande, que la única forma que sea posible que nosotros la obtengamos es que el núcleo de personas interesadas sea capaz de hacer sus doctorados, sus magíster, los proyectos Fondesit, CONICET. Tenemos que ampliarnos para que sea posible hacer este proyecto. Así que bienvenidos todos, como decía Kornelius, a formar parte de este equipo que tiene este interés de análisis. Así que we're very pleased to welcome anyone that will be working in this as a PhD, as a master, as a project, because we need to build up a community interested in this sort of analysis to be able to actually set up something here in Latin America. And well, here we're doing it from Chile, but the idea is to open up the possibilities as much as possible, because it's very expensive. So we need to have this strong collaboration in order to make it possible.
And also, there's one question by Anonymous. It's a research team or development team where engineering can fit in for master or PhD thesis. So I guess maybe the person who's asking is an engineer. I guess yes. I mean, from our end, of course, what Kana mentioned, one important thing is that, of course, you can operate a system like this, or as an end user, so paleontologist, biologist, anthropologist. But you also need people with an engineering background to really know how to operate the systems and maybe also fix them every now and again. So from this point of view, yes, It's very important to count on engineering. But also, I guess, if you're, I'm sure our colleagues here from Comet like to I mean, are open to speak to you as well if you have an engineering background and what one can do, and then perhaps also put you in touch with other institutions in the engineering field. Also. Entonces, any more questions? Any more comments? Not, we've reached, well, we've done almost an hour and 15 minutes. Since hay otras preguntas más, comentarios. Benjamin, thank you. If that's not the case, I guess, no more further comments
we went through
everything, yeah.
Yeah.
And as mentioned before, you can always reach out to us and to Natalie, Joseph, Christian and Erika as well. So, si no hay más preguntas, también siempre pueden contactarse directamente con nosotros, Karen y conmigo, con Joseph, Natalie, Christian o Erika. Yeah? Entonces, thank you very much again for all of your all the participants here and you people watching us. I hope you have a good day wherever you are, and I hope to see you soon in another occasion. Bueno, muchas gracias entonces por su atención, por su interés y ojalá que nos veamos pronto.
Bien. Muchas gracias.
Bye bye.
Nos estamos viendo.
Gracias a todo.
Chao.